Hello everyone. Today I and Anushka will be presenting our project analyzing missing values which we completed as a part of our HAP 786 course under the guidance of Professor Alimi. In our presentation, I will explain you how we prepared and cleaned the dataset, handling missing values and performed likelihood ratios analyzing to identify key predators related to the antidepressant treatment outcomes. Our goal was to explore how data quality and advanced statistical techniques can be improved clinical decision making in the medical health. So in this, I will tell you give you the good introduction of antidepressant, why we use antidepressant. In this project, we focus on the treatment of depression disorders, commonly known as antidepressant care, which involves in a combination of a medication therapy and a lifestyle changes. One of the main pharmacological approaches use antidepressants like SSRIs and SNRIs, as you know. These medications work by balancing brain chemicals such as serotonin, dopamine to improve the mood and overall mental well-being. The purpose of our project is to identify which chemical, procedure, or conditions are mostly predictive of a successful treatment outcomes. To do these, we use a statistical method called likelihood ratios analyzing. These allows us to rank a highlight the most influential predators of symptoms remission, helping clinicians better personalize care for the individuals with depression. In this slide, in this project, where comprehensive data set combines antidepressant treatment history with clinical diagnosis procedure and medication records. From these data set, we define the dependent variables by symptom remission, which represents the target outcomes we are trying to predict. The independent variables including all available diagnoses, procedures, and medication recorded for each patient. These serve as potential predators uh, that we applied for likelihood ratio analysis to evaluate how strongly each independent variable is associated with the symptoms remission. This allows us to identify a rank of most predictive features, enabling a more focused and evidence-based approach to understand the treatment outcomes in the depression. In this project, firstly, we created a separated dataset containing demographic information procedures and medication histories for the patient. This gives us a fundamental view of each patient clinical background. Next, we generated the antidepressant history dataset, which captured each individual exposure to different antidepressant treatments and the clinical outcomes related to the symptoms remission. In the third step, we merged all the datasets to create a single comprehensive view. Then we connected the demographics, clinical events, and the medication use. Finally, we calculated the likelihood ratios for 3 days to identify which specific clinical features, such as diagnosis, procedures, or medications, we most predictive were most predictive of successful treatment outcomes. These calculated calculations helps us in prioritize the most relevant variables from the analyzing. Okay, here for this slide, it gives a use of overview of the AD underscore history underscore DF dataset, which plays a central role in our analyzing. It consists of 7,39,547 records across the 22 variables, making it a highly detailed and comprehensive sources of information. An important aspect of these dataset is all columns have non-null values, and meaning we did not have a handle missing value data here. These made it easier to work with ensured the reliability of our analyzing. These feature including details such as trial numbers, trial start and end dates, and dosage information, number of antidepressant used, number of remission, and the patient demographics like age, date of birth, which such as a rich combination of clinical and demographic data. These dataset allowed us to conduct a true and meaningful likelihood ratio analysis. In this step, we focused on preparation for the data set for analyzing by cleaning and organizing it first. We removed all the duplicates entered to ensure the data accuracy. Then we updated and the standardized column name as format to keep everything consistent. We also applied filters and we made sure of retain high quality data set usable data. After that, we merge all the data and including the demographics, antidepressant history, diagnosis, and into the structure. Finally, we created a two key data frames, target underscore df, which consist of the outcomes variable, and medication events underscore df, which holds all the clinical events such as standardized concept codes. These set up as essential for the conducting our likelihood ratios analyzing effectively and accurately. In this step, we focus to identify which clinical code were most of the predictives of a symptoms remission by calculating likelihood ratios. We begin by loading and cleaning the data and merge the data. Specifically, the target medical underscore events and work file. From these, where we generated a new underscore code by combining all the concepts, vocabulary type with its code, allowing for the standardized comprehensive across the dataset. Next, we filtered out of the incomplete records and the likelihood ratios had not yet been calculated. We focused only on the relevant current targets. For this slide, we displayed results of the likelihood ratios, and here is a visualization you can see under below in the slide. And these codes represent the procedure most strongly associated with the symptoms remission. However, to make the results more interoperable, we translated those codes into the standard clinical names and visualization them on the right as the top 15 predators by likelihood ratio. For example, procedure like mental health screening, cognitive behavioral therapy, and psychotherapeutic assessment. For the conclusion, our project successfully brought together multiple complex data sources into a clean and a comprehensive data set. We carefully handled missing values and removed the duplicates to ensure the data quality. We also built a detailed antidepressant history database, which allowed us to create treatment patterns and outcomes using the data. We calculated and ranked predators throughout the likelihood ratios, analyzing to identify the most influential clinical factors associated with the symptoms remission. Throughout the process, we applied statistical data cleaning and transformed techniques, ensuring the consistency and accuracy across all the variables. We clearly defined and integrated developmental and independent variables to prepare the dataset for analyzing. Overall, the project allowed us to demonstrate practical and technical skills in the integration, cleaning, and statistical modeling, merging skills that are essential for real-world healthcare data analysis. Thank you.